What's up guys, my name is Álvaro Moreira from PSkull, and in this tutorial I'll show you how to create a scene similar to this one here, where you get some rain on a puddle, and you can find a lot of rain tutorials around the internet, but none of it shows how to create raindrops on a puddle. And you know that when it's raining there's always a puddle, and you can always use this same setup to make it rain on a pool or something. Now that we have those three models here, we can start creating our particle flow system. So I will exit the isolation toggle, and on top view, I'll bring those three here to out of my scene. So I'm going to my camera view, and I'll press 6 to open the particle view. Let's decrease its size a little bit, and press Alt W so I can see it better. Let's create a standard flow. So I'll drag the standard flow here, and let's select this particle flow source here, and on select, assign selection to viewport, we can get it there. So on front view, I'll bring it up a little bit. 115 units is fine. And on top view, I will align it to my street, press Alt A, and just to X and Y. And I will increase its size. So just select the particle flow source here. I will hide the description here so we can see it better. And just set it to show 100% of our particles, and increase the size until it gets this whole street here. You can make it a bit higher so it gets the camera as well. So 600 here and 600 here looks okay. Great. Now I have a rain there. Let's increase the time of this timeline. So just press Ctrl Alt and right click to do this. And 120 frames is okay. It's like 4 seconds. And here on the birth, let's change the mid stop to 120, just like our timeline. And let's change this amount. Instead of the amount, let's use the rate. So we know that we have 60 particles per second here. Let's keep it in 60 for a while, and then we can increase it. Position icon is okay. And the speed, let's decrease this speed a little bit. First, let's change this display here to lines for a while, so we can see what's going on here. I'll press Alt X to go to expert mode. And that's our rain. Let's change the speed, make it a little bit lower, like 150. Yeah, it's okay. Now let's give it a variation of 25. So the drops have like a slightly different speed between it. And yeah. And here on the divergence, let's put a really small divergence so the drops don't go all in the same direction. Maybe 10. Great. I don't need a rotation here, and I want to replace this shape. Let's put a shape instance here on top of it. And here on the shape instance, press H to get the particle flow raindrop. And here on display, let's show a geometry now. Okay, now our particles, let's see it on front view. Some of it have a small divergence. Let's increase this divergence for a while just so you can see it better. Okay, no, I increased the variation, so let's keep it on 25. And let's increase the divergence here. Now check it out. This drop is going on this direction. Let's make it go like rotate on that direction with rotation. Let's put the rotation on top of below the speed, and use the speed space follow. So the rain goes to, it points to the direction of the, of it, where it's going. So there's two ways to make it point the right direction. One is change it here, but then it will affect all the other systems later. So I will get this rain here and I will change its axis, so its pivot. So that's our original rain, the raindrop. So I'll affect pivot only and I will rotate it on Y maybe, 45 maybe. Yeah. Now it's all going on the same direction. On the right direction, in fact. At least it looks like. Okay. And here on our speed, let's decrease this divergence to a very low number, like 10. Okay. Now I think it's too big, those raindrops. So here on our particle view, I'll press, just deselect your raindrop and press 6. Otherwise the particle view won't open. Press Alt X again. And here on our shape, let's decrease this size here to 75 and give it a variation, small variation of 20. Now the raindrops have a slightly different size. Now let's create a deflector to create the drops here. So here on space warps, deflectors, let's create a standard deflector. On top view, let's drag and drop it here. In fact, let's make it the same size as this water plane here. So let's select this water plane. Let's see, it have 444 units. So let's select the deflector and let's change it to 444. 444. Okay, don't align the z-axis. In fact, you could, it would be fine. Now press 6 and add a collision test here. And put the deflector 1 here. Let's call it the deflector water. And let's see what's going on now. Okay, the raindrops are all bouncing. So we don't need it to bounce. And we need it to change its shape. So when it collides, it goes to another event. Let's create a new event with a shape instance. And here on our shape instance, we have to put all of those 3 shapes here. And how can we put those 2 shapes, in fact? Okay, how can we put those 2 shapes here? You can use those separate particles for group members, and we can't use group members because the particles are already grouped, but we can use the object in children. So if we link this one here to this one, let's exit the expert mode and let's link it, this one to this one. Now this one is a child of this one here. If I move this one, the other one goes together. So I'll add this one here. So click here and press H to select it. Don't click it, otherwise it can select only one of those objects inside the group. And let's select the particle flow crown. And then enable this option here, object in children. Now the particles, as you can see here, if it's unchecked, the number of shapes are 1. And if you check it, the number of shapes is 2. Now we have those 2 shapes, and it will create only one or the another for each particle. And let's link this collision here. Let's see how it's going on now. Let's show the geometry here on the second event. Check it out, it's bouncing. We don't need it to bounce. We want it to stay there. So let's, here on the collision, change the collides to stop. So when it collides, it's stop. It's speed. Cool. let's look a bit closer to see what happens. The shape's not animated, so here on shape instance you just enable the animated shape option and now it's animated. But as you can see, when this drop hits the water, the animation is at the end because it's using absolute time. In this case, you want to use even duration. So the animation will start only when the particles enter in this event. So when the particle is new in this event, the animation starts for that particle. That's what we have now. We have to rotate it. Let's add our rotation here and change it. You could use the word space. If you use the word space, your particles will be aligned here, as you can see. There's something wrong. Let's check our droplets here. And we have to make sure that this, yeah, check it out. This pivot must be at 0 here. So bring it down to 0. 0 is the base of it, and it must be on the base of it. And the same for this other one here, affect pivot and make it 0. Now let's see what happens here. See, now it looks much better. But check it out. The rotation of it, have a look on this banded one and the highest one here, the highest side. When we have a new one, it will be exactly the same, the highest one and the banded one here. So we have an option here on particle flow that we can use the random horizontal. And now it will be random horizontally rotated, like on this, I think it's the z-axis. Now check it out. The highest one here is there, and now on this one it's rotated in a different way, so it looks completely different. Since it's very small, it looks different now. And as you can see, sometimes it creates this one, and sometimes it creates this other one here. In this case here, the drop got on the street. We will add a deflector now for the street. Back a bit later. Let's just create a little bit more detail. Like when this drop hits the water, it creates this, but let's make it create a bit more drops around it. So here in the second event, let's rename those events here to keep it organized. Raindrop, water drop, and let's add a copy out. Copy out, it's just like the spawn, but it's very simple. It will create some copies of it. You can define the number of it here. Let's create like a little, like just 3, and I will right click here on this sphere and I will align it to right. If you're in, this one is max 15. If you're on 2014 or earlier, you can just drag it like this to the other side. And let's see now, let's create another event with a shape. We want this shape to be a sphere, the 20 side one. Let's make it a bit smaller, like 1 maybe lower. And let's connect this copy here to here. Now it will create 3 particles based on this mesh. And when it enters this event, it will change the mesh to sphere 20 sides. Let's change it from to geometry. And let's change the color to a bit brighter one. Maybe orange. Yeah, and now it creates, but as you can see, it's just don't move there on the center. So I will add a speed here. Where is the speed? Speed here, and I will use a long icon arrow. If you look here on front view, the icon arrow is pointing downwards. It's here. That's my icon and it's pointing downwards. So I wanted to use it the reverse option. So when it hits there, it goes upwards. But I want it to be very much lower, slower. Cool. And let's add a divergence a lot this time, like 25. Let's add a variation here, 25, 45 here, and 25 here. And let's add a gravity so the drops fall back. So here on the space warps forces, select the gravity. Top view, you can create it anywhere. And press 6, add a force here. And here on the force, just get the gravity. And now it will probably be too strong. Let's see it. Yeah, if you look on here on front view. It's falling like really strong, so let's decrease this influence a lot, like 100 maybe. And that's what you have now. So let's give a variation to its orange drops here, maybe 30. So we have some bigger ones and some smaller ones. And here on these water drops here, let's change those colors here. Let's make this one pinkish. This one orange is fine. This one blue is fine. Let's make it a bit bluer. Yeah. Now those particles here, let's give it some size variation as well. So here on the shape instance, just give it 20 maybe. So now we have to make the particles, the rain that hits the street here, it have to emit some drops as well. Because if you look here, it's emitting those drops all over below the streets. So let's add, press F3 again. Let's create a deflector. And let's create a U deflector. The U deflector is a universal deflector. Let's create it outside here. And I have a street low. It's just a low resolution of my street. And let's here on the U deflector, I'll click here, press H and select the street low. Because if you put the high resolution street there, your particle system will take too long to keep calculating it and it will take really slow. And now let's add here a collision spawn. The collision spawn will generate more particles when the rain collides with the U deflector in this case. So let's put here, not a spawn, a collision spawn. Where is the collision spawn? Here, I'll replace this. I will add here the U deflector. Let's call the U deflector street. Just keep it organized. Try to keep it organized really. When your scene gets too big and you try to change something later, like tomorrow, it can get really confusing. So now when it hits this U deflector, which is the street low, which is almost the same size of our street, it will send a new particle to a next event. In this case, this second drop event here. And we can say like how many particles. In this case, let's create a lot, like 20, with a variation of, I don't know, 30 maybe. So let's see what happens now. Yeah, cool. If you see here, this drop, it's not hitting the water. It passed the water and then hit the streets below and generates a lot of droplets. That's because of the integration step here. The integration step will calculate more times the position of the particle, like 2 times a frame, 4 times a frame. And here you're viewing only on the viewport, but it's calculating 2 times when the particle is being rendered. Let's keep it like this for a while, and when we're setting up this to render, we can increase those numbers here, and it will be very accurate here. So now let's see. Okay, when it hits the street, it generates that other kind of frame. I think it's really fine like this. And yeah, I think our setup is fine. So we have the rains hit the water, the rain hits the street. It's generating all kind of mesh with variations and stuff. So the next step now is to optimize this scene, because we have a lot of particles and it's getting really slow, and we don't even increase it yet. Like on the end scene, I want it to have like 300 particles per second or more. So there's a lot of ways that we can improve this scene. Like here, check the orange particles. It hits, it's being generated, and then it goes below the street. We're not seeing it anymore, and it keeps like wasting memory of your computer calculating what's going on here. So what we can do is delete all the particles that are below 0 on the z-axis. It includes the rain and the orange ones. So it's very easy to do it. Let's do for the orange ones first, and then we can clone it to the raindrop here. I'll do it with a data test. There's a couple of ways. You could add another deflector here, and when the particles hit the deflector, it sends the particle to a delete event. But this way, it's much faster. So where's the data test? Here. I'll create a data test here below everything. I'll bring my timeline back to 0, otherwise it doesn't get too slow. And I will link this data test to a delete operator in a new event. So I will drag a delete operator here. And I don't need this display, and I will connect this data test here. I'll call this data test deal below 0. I'll check out update and edit data flow. Now I have to put a output test here and get the z position of all my particles. So with input standard, you can get a position vector. This will get like the x, y, and z values, but I want only the z values. Now it's getting the z values of all my particles here inside of this stuff, inside of this sub operator. And this output test, it only accepts a Boolean value. So it's just a yes value or no. So we want to say, if the z value here is higher than 0, it says no, and it doesn't send the particles to the next event. But if the z component of one particle here is below 0, it says yes, only to these particles, and send this particle to the next event. So to do this, let's create a condition here. In this condition, we'll do exactly this. So it says here, output true if input value, that's the input value here. Let's connect input value, is greater than value A. Value A is here, 0. So if it's greater than value A, it's greater than 0, it will output true. So I want it to output true if this value is less than 0. So if the value here of the particles here is less than 0, it will say yes to the output, and it will send this particle that have the value below 0 to the next event. So let's check it out. Now here, let's see it on front view, and let's pay attention on the orange particles. Yeah, it's working. It's not testing through exactly when the particles, because check it out, this 0 line is here and this one is a bit below. Again, to increase this accuracy, you have to make the integration steps higher here. Let's see it. Like on half frame, but it gets like slower. So check it out. Now on half frame, it's already testing through in the exactly mode. In this case, it doesn't really matter because we're not seeing it. But even though we'll increase this integration step later, so those particles have a better collision on this area. And something else that we can do is delete this water drop here particles, because check it out. Let's see how many frames those particles last. This one, it stops the animation on 36, maybe 35, 36, it doesn't exist anymore. And this one, I think, it's 36 as well. So all my particles don't have to, can be deleted when it have age more than 36, 35 in fact. So let's add a age test here and change it by event age. So it's the age of the particle inside of this event. And let's put it 35 with no variation. So when the particle have 36 frames of life, it will be sent to this event here, which is the delete event, and the particle will be deleted. So even though we're not seeing it, but it's there and it's wasting memory. So when we delete it, your system gets much faster. And now let's check it out. It looks fine. And there's another stuff that we can do to improve it. Improve our system. And it's, we have a lot of particles that we're not seeing here. Like if you select your camera, you can see exactly what you're seeing. Like all the particles that are outside the camera, we're not seeing it here. And if we delete it, we can improve this system. So you can do it using a camera culling. Where's the camera culling? I will put this camera culling on the particle flow source here below the render, so it will takes all the events. And now check it out. Particle flow keeps calculating like the position of the particle, so you have it very. If you select this view, it will get everything that is in this view. If you select this one, it will get everything that is inside that view. So check it out. We have only those particles that we're seeing here. So let's press 6. And I just want to show something that's really important when you're using camera culling. In this case, you can't really notice it, but you have this option here, cull by particle pivot. You have the other one here, by bounding sphere. I'll create a teapot on the scene so I can show you it a bit better. And pretend that this teapot here is a particle, a really big particle. And I'll just bring this pivot a bit higher. And pretend that this is a particle. If you're using the bounding sphere option, if a little bit of the particle is out of your camera, the particle will be deleted. Like here, it will disappear. So this option is not that good. But if you're using the particle pivot, it will delete the particle if the pivot is outside the camera. So if it's here, you have no particle anymore. And sometimes you can really notice the particles disappearing here. And a turnaround for this, it's like really simple. You just have to create another camera on the same position. So I'll select this camera and I'll press Ctrl V. I'll call this camera to camera culling. I don't want it to be an instance. And let's see on its view here. It's now the camera culling view. And then you can increase the field of view. Let's make it like 52 maybe. Now it's seeing a bit wider than the other one. If you select both of the cameras, now you can see it there. But now here on your particle flow system, you can deactivate this option and put your camera culling here. Camera culling. Now it will delete particles based on the camera cooling, and here you can press C to select your other camera, and now it will delete the particles that other camera is seeing. So it works much better like this. I also have to delete those particles here, the blue ones that are below 0. So press 6. I'll get this dot test below 0 and just bring the timeline back to the first frame. And I'll hold shift and drag it to this event. It can be an instance. And I'll connect this one to the delete event here. Now let's see. Great, now we have no particles below Z, below 0 on Z, and it improves a lot our system. And now we can cache those particles. So let's add a cache disk here on top of the camera cooling. So it caches the camera cooling as well. And then you have to select where you want to cache it. Like click here and I'll create a cache for folder. That's my other tests there. I'll call it rain. It will ask if you want to make this folder your default cache location. I don't want it. And yeah, I forgot if you want to apply a material to your particles, you can add material static on top of everything like here. Or maybe if you want to have different materials in some events, sometimes let me just show you how to do it. So I'll add it here on my first event, and then the material static if your material is not animated, and I'll create just a standard material, and you connect this here. If you're using the compact material editor, you just drag it like this here. So, but I like this late. Then you select like this event here, it doesn't have the material as you can see here. When you select the event, you can see the materials here. So you can select the first event and click here downstream materials. Then it says that 3 events were updated. So this one, and even the deleted one. So now all these events have another material. And if you want to have a different material in this one, you can just put another material static there. And now we can increase our number of particles here. Let's put 300. It will start getting very slower. And if you want your scene to start like raining already, you can put some value here like -30, -50, but I don't really want it. And now let's increase the integration step here. On viewport, I want to increase it to half, but in render, I want to increase it on 1/80th frame. So it will calculate the position and everything of the particle 8 times in one frame. And here on the cache disk, I also want to use the cache disk on viewport and render. It's much better this way because when it's rendered, the particle system is already cached and it avoids a lot of problems, because sometimes some problems happens when the particle flow keep calculating everything before render each frame and stuff. So now that our scene is all optimized and everything looks okay, let's cache it. So you just press update here. Let's bring it here. You can switch off the update viewport so you will not see it on the viewport, but I really want to see it, so I'll check this option. No, I don't want it to see, I don't want to see it. And I'll press update and I will stop this recording. So it was very fast, it took like less than a minute maybe to calculate everything, and as you can see, we have a lot of problems here. I don't know why. So I just cached it again with the update viewport zone, and it looks fine now. And that's our final scene. If you have a look on our advanced rain here, you can notice that this plane is kind of distorting on the render. It's just a noise material applied there with I'm show you here. So that's our rain material. You should make it like really reflexive and stuff. And this one, let's call it water. And here on the bump, no, I added a noise. Where's the noise? Noise, and with a lower size here, like 10, it's the, you can base this on the grid units here. So this square have 10 units, so a noise size here of 10 looks fine. And so I animated this phase of the noise. So I could notice that 1 unit per second. So if you have 4 seconds, you can go to frame 120 and animate it like 4 units. And it will look fine. And that's it. I hope you like it. And I will make the final scene available. I rendered it in V-Ray, so you can have it with all materials and stuff. Thanks for watching. Bye.